Hey everyone, this is Scott. I'm from KiteAI. This is second session of live coding. Today's session, I'm going to implement the x402 protocol, and then we'll go see from there. So, what is x402? 402 is actually a HTTP return standard, similar with 400, which usually is client error. 44, 44 is probably one of the most famous ones. Page not found. And 500 is like server error. X402 is actually a very old standard, happened during early 2000. It's using as a payment standard in this case. So basically, if I want to access some resource, if website server side return 402, it requires some payment. It is actually client server's responsibility to implement it. What's actually what's payment standard they can accept it. But I guess it never took off. Most of people still use credit card to make payment. Then, but the time has changed for this year because nowadays we have AI agent rising. In this case, it grows exponential growth. I explained in the last session. Currently, AI agent is almost like 2 times the most loss growth. And then this enable a new, just a review of X402. X402 is heavily promoted by Coinbase and BaseChain in this case. So not only it can serve as a HTTP standard for user payment, but it also the most important thing is that it's open a new door for AI agent to make payment. No matter it's for API access, paywall access to data, digital services. So that's why this new rising of the agentic AI just give a new birth for the x402 protocol. And this x402 protocol eliminates the needs for API key, subscription, manually payment processing, and this allow real-time machine native transaction use stablecoin, use blockchain. So this is actually particularly important because as KiteAI's thesis here, most of the transaction, most of the value later on will be done by AI agent. This is actually one of our courses. The AI agent will help you to schedule meetings. AI agent will help you to do all types of activity, including like scheduling, reasoning, do deep research. It's already happening with the OpenAI deep research. And then with also yesterday, OpenAI released an OpenAI agent, which is also a brand new part, can help you do all the agentic stuff. But today, if you think about the existing payment, it's still pretty limited. You have one-time payment, use credit card. You have monthly subscription. Most likely, if you're using, for example, if you're using a GPU website or some website, you deposit money into a credit and then consume credit from the individual website. In this case, you have large portion of your money in different platform. In a very just fragmented in different platform. And then it's actually not very convenient in this case. So that's why with machine speed agentic AI rising up, I think it actually makes sense to have a machine native payment, machine to machine native payment. That's why the X402 has a new, promoted by Coinbase has a tons of adoption and attention for the last few months. Why X402? Most of this is actually come from Coinbase white paper X402. I think it's pretty straightforward. First is that currently one of the most important things is that when you actually want your AI agent help you do stuff, it's stuck at authentication and checkout page. Even for humans, whenever you go to buy airport tickets, whenever you want to make a payment, it's probably anywhere between 10 columns to 14 columns you need to fill in this case. It's tedious for human. It's actually more tedious than for AI agent because they don't have direct access to browser. They actually need to use browser or browser base to access to the browser. And then you have the ID issue with agent. Sometimes you just don't want to share your ID with agent because the agent can do things. If your agent is to go wrong, it can hack things at machine speed, spend money at machine speed, which is something you definitely don't want to happen. So that's why that's why it's actually not ideal in this case to share the ID and the wallet with AI user, with agent. So if we think about the the existing process without x402. For AI agent, you need to create an account. For example, you have an AI agent using Gmail for you. In this case, you need to create an account. Create a Gmail account for the AI agent, and then you may need to have payment method, attached to it. For example, your Gmail may asking you to pay something in this case, and then you subscribe as a monthly premium Gmail user. In this case, you can buy the credits from there, and then you need to get API key to allow agent to access. And once everything is done, you can make payment. In this case, you need authentication. You need credit card access. Assume that you're willing to share your credit card with your agent. But use x402 is much easier. You just need to specify how much is needed in what stablecoin on what chain. You don't need to log in. As long as the server side receive payment, you don't need to have account setup, and you can have instant onboarding as well in this case. And then additionally, because it's a blockchain-based solution, you can do tons of the thing on top of x402. For example, in this case, x402 actually eliminate friction, allow AI agent to pay per use with 0 manual steps. But x402 is actually only an HTTP standard. Built on top of blockchain, you actually can use tons of the blockchain, blockchain benefits in this case. So, for example, in this particular case, I break down the benefits into 3 different parts. First is the settlement fee part, how much is going to be charged. And then the finality part, how much it will be finalized for the payment. Is there any chargeback risk? And is it programmable in this case? It's pretty obviously for the fee part. Blockchain-based solution is much better than other solutions because no matter it's for credit card, PayPal, you're going to be charged 30 cents plus 3% fee. If you have AI agent make payment at machine speed, this is actually not an ideal situation. You don't want to pay. For example, currently, while the most common payment is for GPU rental, most of the GPU rental companies, like the serverless GPU rental companies, is already charged like seconds level. You can rental GPU at per seconds level or per hour level. But regardless of seconds level or hour level, in this case, they only charge like 0.1 cents per second. You don't want to pay 30 cents just do this streaming payment. So that's why it's actually done makes sense. But use crypto payment. No matter if you use Ethereum, is much expensive gas fee. Use KiteAI is actually much cheaper fee in this case. So the fee is actually several level of magnitude cheaper comparing to credit card, PayPal, or traditional payment trail. So fee part is actually pretty obviously. Settlement finality is pretty obvious as well. Most of the traditional payment settlement take anywhere between hours to days. But most of the newer blockchain, no matter it's base chain or KiteAI chain, it's only like 200 milliseconds, 500 milliseconds, or 1 second. Usually the settlement finality is much shorter. And also you don't have chargeback risk. This is actually pretty important in this case because sometimes you have, particularly if you're a service provider for AI agent, you may have agent exploited you at machine speed, get all the services provided by you, and then just get it for free. The last part is programmable is pretty important as well because take most of the payment today, it's not as simple as I give you money and then get service back. Most likely you want to put into an escrow contract and smart contract, and then you're asking for the service, you verify the service, and then change ownership of payment from you to the service provider. So in this case, programmable money is actually a very important concept. Most of the service in today's world, in machine world, you don't trust machine from certain perspective. You don't trust machine. So that's why you need to have this cannot do evil. Don't do evil to cannot do evil. Don't fraud me to cannot fraud me in this case. So programmable money to guarantee you cannot fraud you instead of don't fraud you. Okay, so this is actually all the concept for today's live coding session. I do have something ready in this case. For example, today I have my my old browser Jarvis ready. again, so this is a personal agent run locally. I usually do it, no matter it's browser use, etc. It's actually a React agent. If you look at this Jarvis, it's a React agent. Means that its agent can sync, act, and step to the next step. So it's just keep reflecting itself. It's a React agent. So that's a local setup. It can use browser use. It can use KiteAI network. It's integrated with KiteAI network wallet and transaction, and it integrates with the example agent server. And then example agent server is actually a server providing services. So today, most of the coding will be done at this server level. And then we have some setup for this server. First is that I set up CI/CD ready. So this server is linked with GitHub CI/CD, and then it will deploy as a Docker image, and deploy as a Kubernetes pods in our Argo CD DevOps, CI/CD framework. If you're not familiar with this, don't worry about it. It's just it's deploying cloud services whenever you're checking the code in the main branch, and then the cloud services can serve this request, and then you can serve the request. It seems that the endpoint is healthy online, so you can use it anytime. So if we go back, yeah. So the example agent server is a REST server with actually most of the code at cursor generated payment and verification. And let's actually verify a few things in this case. Okay, let's verify a few things from this case. First is that I have the server app. This is actually a server app. This has a list of results here, and then I can query the server for different services. For example, let's actually try something simple. Let's say what results available. Okay, so it mentioned it has 3 results available. Bitcoin white paper, weather report, Last of Us season 2 in this case, which is all actually just as a demo case example. And then let's actually see what it can do in this case. I need to have verbal. I need to have this verbal turn on to see what status return from the server side. Notice that when I actually try this, it mentioned FOO2 payment required in this case. So because I want to access these results, it say, hey, you need to make payment to make sure you are able to access results. And also from server side, it say, hey, you need to make payment to make sure you have access to these results. And then you can see what actually required here is that you have a session ID. It give you a session ID. It give you a category you can make payment. Category is access to. Which network is making payment from? What's the currency? What's the amount of the payment? And receiver address in this case. And then we're going to reproduce this. We're going to look at details. But for now, let's actually directly see an example case we actually make payment. This is actually an example successful payment link I did. Okay, so now you can see, because I made a payment earlier, I have a wallet signature, I have a payment transaction ID, transaction hash, and then I make a payment here. That's why I'm able to access Bitcoin white paper in this case. So from the server perspective, first is that I access what's the list of results available. Second is that I want to access Bitcoin white paper, and then because I make payment, and then server side can verify and make payment, it give me access to the Bitcoin white paper. All right, so this is actually a manually access it. Let's actually try let the agent to access it. So in this case, because KiteAI agent, again, so the reason KiteAI agent are able to do this is that it's integrated with KiteAI network. It's also integrated with this local example agent server. So you can export list of results available and then figure out what results you're looking for. And then if the result require payment, it can make corresponding payment from there. So, okay, let's try this. And then list resource available and give me Bitcoin white paper. All right, so we can see what the agent is actually doing. It's actually repeat the process I did earlier. But in this case, agent is reasoning through each step, think about what to do for each step, and then go through all this step, and then access the Bitcoin white paper, make transaction payment, and then now fetch the resource and get Bitcoin white paper. Let's see if it's working. Cool, it's already got Bitcoin white paper. Let's see what's happened under the hood. You can see this is actually exactly the repeat manual process I did earlier. First is that it's trying to list the resource available, like what resource are available for this agent to be explored. Second is that it's trying to access Bitcoin white paper. And then this last step is doing the payment to make sure it's able to access Bitcoin white paper. And if you're looking through this logic chain, this React agent, Majority's React agent logic chain, the first tool is trying to do is list the resource and say, hey, this is a list of resource available. And then it's trying to fetch Bitcoin white paper. And then it will it's telling them exactly the same thing, which I showed earlier. You need to make payment on KiteAI network. You need to make payment to this receiver address. This is actually how much you need to pay. And then in this case, it gives you a session ID. The reason it needs a session ID is that I don't want to make sure, as a server provider, if I'm providing this service to my client or user, I don't want to actually someone copy me a payment link and then reuse the payment link for repeatable access. It's like account sharing in Netflix. I don't want you to do that. Particularly for this case, you can account sharing with the rest or just payment. This is a payment link anyone can use. Then you can have billions of people use the same payment link. So that's why it's giving a session ID. We'll drive down to more details there in this case. And then once you have a session ID, the agent was able to make a signature. The agent is actually signed a signature. The agent was able to make a payment transaction. Let's check this payment transaction on KiteAI network. Yeah, so it happened exactly 2 minutes ago. And the agent used and transferred like 1 cent for KiteAI on KiteAI chat. And it has a payment transaction. And then the transaction hash was going through. So in this case, it actually paid 1 cent to the server side. Because it's payment 1 cent to the server side, using this client ID, in this case, the wallet signature verified on this client ID. And then the server side gave access to Bitcoin white paper. So this is actually the whole life cycle for x402 in this case. So if you look at the scenario here, this is actually scenario 2 in this case. So how the life cycle works is that first agent is trying to get Bitcoin white paper to the server side. You can from user or from agent. If I calling through the cur command line, it's actually from myself directly. But if I'm using my agent to call, in this case, it's actually calling from my React agent locally. And then it first trying to get Bitcoin white paper, and then it requires photo payment require with session ID, with Kite, with receiver address. And then in this case, the user need to send payment transaction on KiteAI chain. This is actually KiteAI network. So the user need to send transaction on KiteAI network, and it will get the transaction hash back for the payment, and then it will generate wallet signature your session ID. The key here is again to preventing payment resharing, like account sharing, payment sharing in this case. So my payment use this wallet will be different than your payment use your own wallet in this case. So in this case, every single wallet requires minimum 1 payment. You cannot share this payment among different wallet. So once you have this wallet signature your session ID, you can access this user session ID, no matter it's transaction hash or wallet session ID, transaction hash, wallet signature. And then in the process, verify the wallet signature, get signer wallet in this case. So you want to make sure the signer wallet is exactly the wallet you're using in this case. I'm not impersonate someone else's wallet. And then we can verify the transaction / come from sender wallet. And once the transaction is successful, the server side can return Bitcoin white paper. Okay, so even though it sounds pretty complex, but actually most of the code is generated by Cursor. It's pretty simple in this case. So if you look at the server side, if you look at the REST server side, you have this API with events, results, and payment. And then under each routing, for example, results, it just lists the results available. No matter Bitcoin white paper, weather report, or Last of Us Season 2. Under payment, we have this create payment request, verify payment, etc. And then events. Events is actually for streaming payment. We're going to not use in this session. And results here is actually different data model for Bitcoin white paper, for weather report. And payment side is actually majority of the business logic. And then, majority of business logic. For example, you may have verified payment, verified signature, verified transaction from server side in this case. And we also have a Python client to verify. All right, so let's see if I have any comments here. No comments. Okay. I'm going to write some code to, this is actually a relatively complex scenario, but let's start with something simple in this case. I'm going to spend some time implement a very simple scenario here in this case. The simple scenario here is that I'm going to use a simple payment wheel in this case. Say, hey, instead of saying, hey, verify the session ID. Here, we're going to use something extremely simple. Say, just verify if you got payment or not in this case. So we're going to simplify. If you're looking at if you look at the client side, so we're going to get rid of session ID, make it an extremely simple part. More likely your paywall access. Think about your paywall access to this news website, and then we can get rid of this and do a simplified part. So how I do it is that I'm going to use Cursor help me write all this boilerplate code. Let's try to add a Cursor. Let's add a new endpoint called Ethereum white paper, similar to Bitcoin white paper. I don't need session ID for the Ethereum white paper. Simplify verification logic to verify session ID, to verify the wallet signature. All right, let's actually use Cursor to finish the boilerplate code, so we can code on top of Cursor in this case. So we also have this GitHub here. So this should be up to date with May branch. All right, so Cursor, let's actually verify this one by one. First is that Cursor add a new resource here in called Ethereum white paper. This looks good. And then it has a new endpoint called Ethereum white paper, which looks good to me. And then some import. Okay, this looks good to me. And then from the router side, nothing changed much from router side. And then from resource side, it has added a new model called Ethereum white paper. Yeah, so this looks to me. Actually, what content here doesn't really matter here for now. And then what else it added? Cool. I think this is everything added. Let's check. All right, so in this case, it should have list results available. Let's restart server and check. It should have the list results available. So you have Ethereum white paper there. But if we're trying to get Ethereum white paper, let's see what happened. Okay, so this actually didn't do any payment check. It just gave you Ethereum white paper auto box in this case. So that's why we need to add some payment check. So what we need to do is that we need to check the routing side. Yeah, so it just return Ethereum white paper directly. Let's in this case, because we don't need all this, we just need we don't need session ID, we don't need wallet signature. We just need transaction payment. Let's use the cursor again, see what we can do. Add in Ethereum white paper. Add the verification for transaction hash, but not the wallet signature and session ID. Cool. It's still adding this boilerplate code. It's actually not very intelligent in this case, but that's fine. We can fill in the information ourselves. Okay, so now, so it's easily check if there is any transaction hash. If there's no transaction hash, it will reject you. But the transaction hash alone is actually not working because it's like you can give any transaction hash and say, hey, this is working. You just give a transaction hash doesn't mean that it's a valid transaction hash. So we need to verify payment here. Use a transaction hash. So what we need to do is that we most likely need to refactor this. We most likely need to refactor this method to add a transaction hash here. All right, so let's refactor this, verify the transaction hash. With no session ID. We can remove this. We can remove this as well. We don't need, okay. We don't need wallet transaction. We just need a transaction payment. What's this for? Oh, it's for how much the price is. We need to define a price for it as well. This is a pricing part. It's Ethereum white paper, regional, metallic. Let's define a different amount, just make sure it's very, very different than others, so we can verify. All right, so in this case, you are able to get this verification without this, and then you just need the transaction hash and payment. Let's see what we need to modify here. We don't need wallet signature and session ID here in this case. So let's see. We just need to verify transaction. I would say just copy this to a different method. Just verify access with no session ID. Cool. Then we can get rid of all this wallet signature verification. Just verify transaction. Oh, it gives this expected sender. Let's make it a null. Okay. Sorry, not this file. Okay, now I don't have the warning. So what here you do is I just verify a transaction hash. Given a transaction hash, just verify a transaction hash. And then we need to modify the logic here. So it should be not extended sender, and in this case, so if expanded sender is actually null, you don't need to verify it. So sorry, should be expanded sender. If expanded sender has address, you verify it. But if expanded sender don't have address, it's null. In this case, we don't verify who you make payment from. You don't verify it. Do we need this elsewhere? No. Okay, should be fine. So in this case, it's verify no session access. All right, so this will call the method here. So what this step do is that it verify the price. It's given a price. It's given a price and verify if the price is paid. Underline, it's check the price and check the price if price is paid here. Oh, no. Okay. If not verify, okay. Let's go through the logic again. Let's through the logic again. I'm actually a little bit lost. Let's try to through the logic here. In this case, we verify access no session. All right, so let's go through the logic again. You're trying to go to list the results available in this case and trying to get Bitcoin white paper. Okay, so what we need to do is at resource here. This should be Ethereum white paper. Verify and get Ethereum white paper. You check verify payment transaction hash is there, and then it's trying to verify the payment. So underlying verify the payment is looking at transaction hash. It get price, it get resource price for this Ethereum white paper, which I just said like 3 cents. And then it's trying to verify the access with no session. When doing the access, verify the access with no session, we check if the payment transaction here. Okay, I think we can remove some logic here. It's some repeatable logic. We can remove. It verify the transaction in this case if it's valid. So verify transaction here is that it's going to use Ethereum Web3 client to get transaction. It verify the sender side, and then sender if it's is equal to the expected sender. Here, I didn't pass any expected sender because this is actually implementation require no verification for the sender side. And then it checks the receiver side and verify this receiver should be this agent server receiver. And then it verifies the required amount, make sure the transaction amount is larger than or equal to the required amount. You can send more, but you cannot send less. Seems right? So once the verify, you return true. Return true. So then so this will return true because it's verified. If it's not verified, we don't need a session ID. This requires no session ID. If it's not verified, just return title, description, amount, error message, etc. And then don't receive session ID. Just return x402, otherwise return true. And then if it returns true, we give you access to Bitcoin white paper. Cool. I think the logic is finished. Let's try. So here we just need to add the logic here. It means that it failed verification. All right, I think we got everything here. Let's try, and then let's queue the server. Restart server, okay. And then let's get Ethereum white paper. Cool. In this case, you actually need a transaction transaction hash to make it. But let's actually give it a transaction hash in this case. So for example, this is a request I sent earlier with existing implementation. We can get rid of this transaction. We can get rid of word signature. We can get rid of session ID. We just need a transaction hash and change it to Ethereum white paper. Transaction payment too low. Yeah, so I set it to be a larger transaction amount. So in this case, for example, I guess this transaction ID is pretty low. So that's why it's returning this error. Let's check what's the transaction ID. Yeah, it's 2 cents. It's not meeting the 3 cents bar. Okay, so this is actually as expected. Let's actually have an agent to make payment. List results available. Resources available and give me Ethereum white paper. Cool. So if everything goes well, this will actually make a payment of the right amount. Oh, okay. So this requires client change as well because it requires session ID. So, it didn't go well. That's fine. The client side expected a session ID to make payment. Let's actually modify the client side corresponding. So this is the agent side, client side, and then if we don't need session ID, let's take a look. So this is my Jarvis agent. It helped me do browser search, all the stuff. I think I showed it during last session as well. So this is actually the MCP integration with the server side. In this case, you can see a lot of smart contract integration, and then yeah, so requires a session ID here to do the payment. I think this is exactly the error message I see. Yeah, so session ID required for command. Okay, so let's get rid of this because the goal here is that implement a payment word that requires no session ID. Let's get rid of this and try again. Okay, list results available and give me Bitcoin, sorry, Ethereum white paper. Okay, so it requires payment. Actually, I think I didn't return how much payment need to pay. Let's check if it requires how much payment need to pay here. If you don't, server side don't give you how much you need to pay, the agent need to take a guess, which doesn't make sense. I guess it has in this case. Oh, okay. So it went wrong. It's directly go to browser use. Let's see what's went wrong here. Let's say first is if it's a client error or server error. Let's say the server side. Server did indeed give how much you need to pay. So it's a client error. Let's see why client actually making mistake here. Still need session ID. Okay, let's check the logical client. Why client still needs session ID? Because it's trying to generate signature. And generate signature requires session ID. Otherwise, it's failed to generate signature. Okay. We probably need a process payment without session ID one. Let's do this. Let's do this. Receiver address amount you definitely need. Send transaction, you don't need to generate signature if you don't have to. If not, if session ID, you have signature. Is this field available? Okay, I need to define this field. Signature string is none. Okay. If transaction hash, you have session ID, signature, transaction hash, amount receiver. These two may not be available. So what we're going to do is that let's actually, if session ID, you have a result, session ID equals session ID. If signature, not signature, you have a result signature and signature. Remove these two. All right, let's see if it works. Is the results available? And give me this white paper. Receiver address is required. Okay, so it's not passing receiver address. Let's check what's the error here. It's not passing receiver address. Receiver address is actually required for command process payment. Let's check client again. Again, this is a client error in this case, so it's actually not server error. Why is it not giving receiver address? Let's check. Is it not giving receiver address? We do have a receiver address here. Yeah, you do have a receiver address here. What happened? I guess it's a communication issue. You don't have a receiver address. Travis call X results fetcher. You don't have a receiver address. Okay, let's see why receiver address is not available. Wait, it didn't call this resource payment. I'm wondering if it's actually calling correctly. Let's try again. Let's try again with Travis. List resources available and give me a zero white paper. So far, so good. You have payment transaction hash required. Yeah, it's repeat policing this. It seems that agent is stuck. Agent is stuck here. So okay, so let's say why agent is stuck here. My personal agent. Say look at available result and error message. I can say access speed require payment processing. Approach this systematically. First, let me check if there is a session ID available for initial results attempt in this case. So it's calling fetch results with Ethernet paper fetch results and then say, hey, it's still trying to get the session ID. Why is it still trying to get session ID? Okay. I understand why. So it's never passed to the second page. It's always skip this page. You don't have enough information. Let me review this one. Let's try again. So okay. So let's try again. Oh, I know why I say differently. Because in this case, I pass the transaction hash ID. So I say different than the agent. The agent is pretty confused because this is actually what the agent saw. Sorry, let's actually revert code. I know why now. So if we reverse this code, so what agent saw is this payment transaction required. So that's why agent are extremely confused in this case because it don't see the information like this. You should show the information like this. So that's why the server side, this server side short circuit is actually wrong. So let's remove this short circuit logic. Okay, so in this case, it's actually the agent should be have enough right information here. Let's see if it's working. Yeah, so you can see it's already working because so if you notice that this is actually exactly the amount, right amount. Swicency is exactly right amount from Ethernet paper. So you can see it's already working. And it's making a correct payment. It's making a correct transaction payment. This should be happened just a second ago. Yeah, exactly. It happened 11 seconds ago. And you are able to get results. You're able to get the Ethernet paper. Cool. In this case, it's exactly as expected. Awesome. This is exactly as expected. First is that I'm trying to get list of results available. Then I want to access Ethereum white paper. It's a full to payment required. And then I make a wallet agnostic, session agnostic payment of Swissons, which meet criteria for AI agent, for the server side. And then the server side say, hey, you did make a payment, and then let's go actually grant you access. So in this case, everything else is working. So this is a scenario we just implemented. We have get Ethereum white paper. and then you have like a payment required in this case. You just how much and receiver address. You don't verify who is paying this in this case. You don't verify who is paying this. You send payment transaction, you get payment transaction hash for payment, you get result, and you verify transaction hash, and everything is great. You get Ethereum white paper back. Okay, so I think everything here is good. Let's try to checking this to the server side and then deploy it on server side. So I can deploy this in cloud, access from a remote cloud side instead of everything run locally. All right, let's try to check a different branch. One-time payment rule. Right? And one-time session agnostic payment rule. Cool. Let's check in the GitHub. Merge request. And then waiting for is the CI/CD actually get deployed in this case. Get deployed here. Once it got deployed, we can try get from server side in this case. All right, cool. So I guess we're about time. I was originally I was planning maybe to implement a more complex situation like time session based payment gateway. The scenario for is a streaming based payment in this case in the future. I guess we don't have time to implement, but today actually we implement something pretty cool. You can see how simple it is actually for AI agent to make payment. It's as smooth as writing a code. It's as smooth as execute any type of code in this case. You can say what makes this really good is that now AI agent, like my Jarvis AI agent, don't need a credit card in this case. It can just make payment at machine speed, and then it can make payment at machine speed, and it has power to make payment at machine speed as well in this case. It just check how much money, for example, in this case, if you look at the logic flow, is that look at what's available, how much money I have in my testnet wallet, and then how much does it need, like where should the receiver address is, and make payment. And then the AI agent was able to make payment at machine speed in real time in this case. So this is actually what we show today. Cool, let's see if the server side is deployed. The server is deployed. Let's see if the Kubernetes is deployed here. Okay, now doing a deployment here. So the final goal here is that instead of doing this everything local, like this is actually local service agent, we're trying to use my personal agent interact with a remote server, like remote server. So in this case, we can verify this is actually working on a remote server. Oh, it's still triggering CI/CD, I guess. Let's rethink again. All right, now it's the remote server side. Let's verify the remote server first. So instead of the client side, use local server. Let's use remote server here. Yeah, working as expected. And then we can change the Jarvis to use remote server as well. All right, so let's see how it works in production. So list resource available and give me Bitcoin, not Bitcoin white paper, Ethereum white paper, what we just implemented. Notice that instead of query locally, in this case, it should query remotely. So you shouldn't see anything here. You should just query remotely in remote server. So you don't see anything here because it's calling remote server side. Oh, okay. It's successing. It's working. Yeah, it's working. Okay, now you actually get Ethereum white paper again, not calling from local, but calling from a remote production server. Let's try the payment transaction hash and see if it's working. Yeah, exactly. Okay, so what we do today, the live coding, is that implement the scenario one and deploying production in this case. So I have my local agent calling the production server in this case, which the production server is the example agent server on Go KiteAI, and then calling from remote production server and then receive a payment required. It make a payment of 3 cents on KiteAI blockchain. Once the payment is given, and then it be able to access the server side will verify and give it access to Ethereum white paper. In this case, it can be any resource. It can be, it could be like data, it could be like GPU access, it could be like any type of resource. And then particularly, if you notice that most of modern GPU access, like a model, like server access is actually paying per second. In this case, and KiteAI actually I'll probably do another session. KiteAI future will support this streaming payment. So instead of paying like a $2, $3 for monthly access or daily access, you can make payment at every single second or even less, and then to get streaming payment. So for example, for use case for like this GPU rental, you can make stream payment to make it work in this case. And this is only available in KiteAI network. All right, so thanks for coming and then take this live coding session for x402. Today we actually work through x402, which is a standard pushed by Coinbase and few other company as a native, machine native payment standard, in this case for agentic AI. And then use x402, you can think how easier it is, just comparing how easy it is for agent to make payment comparing to human make payment use credit card, and you can see how easy it is, how fast and how easy it is. Not only it's extremely simple and smooth, but also it's pretty cheap as well. So blockchain payment here can charge at extremely low fee. It could be like less than 1 cent in this case. So in this case, it can support you to make stream payment. You pay like GPU at every single second in this case. But all other existing traditional payment rail is actually not fit for this use case because it either charge you 30 cents or 3% fee. And then today I just a live session, do just a live coding, do a simple payment gateway, use this Ethereum white paper as an example, as a data resource. It could be like a GPU resource, could be like data resource. it could be like service resource. But in this case, I just use Ethereum white paper as the service resource, and then make a payment to get it. And then the live coding session is actually didn't verify session ID, but previously I did a session just verified who is actually make payment and session ID as well. Thanks for coming for this live coding session, and hope you enjoy the session. Bye.